In this video, we're going to be looking at parabolas under the study of conic sections. If you find this video helpful, share, like, and subscribe. Parabolas. So we're going to be looking at the geometric definition of a parabola. And it is said that a parabola is the set of all points in the plane that are equidistant from a fixed point called the focus, okay, symbolized by capital F, and a fixed line L called the directrix. Okay, so let's look at some key terminologies that we will be using throughout our study of parabola. The first one is, of course, the word parabola. That is going to be the graph of our studies today. This is a U-shaped graph, and it's called a parabola. The second thing that you have to know is the vertex. The vertex is always in the middle of the parabola. The next is what you call your focus. The focus is very essential part of our study in here. Also the axis, okay, in your earlier quadratic studies, this axis, also called the axis of symmetry, is going to be cutting or dividing the parabola into two equal parts that they are going to be mirroring each other. And the last word that we're going to be looking at here and using most of the time is the word directrix. The directrix is going to be the line that is actually equidistant from the focus to the vertex, and from the vertex to that directrix. They are actually equidistant in nature. Okay, so let's look at once more our parabola in here. So there are things that I would like you to understand in here, that if I'm going to start from the focus and put a line or a point on that parabola, we call that point pxy, okay? This point going to directrix is going to be equal, okay? It's going to be equidistant when it comes to the distance. This is going to be equal. So let me create one more example. I'm going to create one from here, and this one I'm going to say S, okay? That's another point on the parabola, and it is going to be considered equidistant from this point xy to the directrix once again. So these are going to be equidistant in nature. Now let's look at the focus. The focus is actually symbolized by the capital F, okay? So since we are looking at a parabola that's going to be concave up, or it can also be concave down, it means it can be opening downward. Now the focus is actually located at the y-axis, so the focus coordinate is going to be 0 and p. Now the p represents the value of our y coordinate in here for the focus. Okay, another thing that I would like you to remember is that the distance of the focus from the focus to the vertex is actually the same with the distance of vertex and your directrix. Okay, so this is going to be discussed further. What is the directrix all about when we're going to be doing some word problems and real-life application in this video. Okay, so we're going to be looking at vertical parabolas this time. Okay, let's look at their characteristics, and also we're going to be dealing with parabola with horizontal axis. So in your earlier quadratic or we call it parabolic studies, you are just dealing with this type of parabola which is in its vertical axis. Now if we're going to go further on this study, so we're going to be looking at the equation of the graph. That's going to give you x squared is equal to 4py. It is a parabola with the following properties. First, the vertex, okay, we said about the vertex earlier, is located at the point of origin 0, 0, and the focus is actually inside your parabola, and its coordinates is actually 0 and p. This is your focus. So take note that your focus is always inside your parabola. It cannot be outside. But the directrix is the one that is actually outside your parabola, that's behind the vertex. Now, if you're going to be looking at the other graph in here of this inverted, we call it actually concave down. Okay, that's because the parabola is going to open up if P, okay, the value of P in here is going to be greater than 0. Okay, so it's going to be concave up. We also call it as concave up. Concave, CCU, okay, concave up. While when it's going to be opening downward when the value of P, just like in this case right now, this value of P is going to be less than 0. So also we term that as your concave down. Okay, concave down. These are the terminologies that we used to use when we were dealing with our basic understanding of quadratics in your lower years. So in addition to this conics parabola, we're going to also be looking at parabola with horizontal axis. So if you're going to be looking at these types of parabola, it may be very weird to all of you, but these are also still part of your conics studies on parabola. So let's look at the graph, the equation of the graph. That's gonna give you y squared is equal to 4px. This is a parabola with the following properties. The vertex is still at the origin 0, 0, just like what you can see in here. They are both still at 0, 0. Now the focus now, because the focus, as I said earlier, the focus should be inside your graph, then the focus is also located at the x-axis. So you can see that P is going to be coming before the 0. That is the y-coordinate of your focus. And the directrix, the line behind your vertex, is actually, the equation of that is actually x is equal to negative p. Now, compared to your vertical axis, your vertical axis has actually a directrix of y is equal to negative p, because the directrix is actually lying on the y-axis for this concave up parabola, or we call it parabola with vertical axis. Finding the equation of the parabola. Okay, so let's go for number 1. Find the equation of the parabola with a vertex V at 0, 0 and focus at 0, 2 and sketch its graph. Okay, so let's understand this one. The focus F is 0, 2. So in my graph, where can I find my 0, 2? My 0, 2 is somewhere here. Okay, if this is 2, then it's somewhere here. And the vertex is at 0, 0. So it means that my parabola will be opening this way. Okay? Now, what is required in here is that we're going to get its equation. So with these given requirements, then this parabola is actually in the form of x squared is equal to 4py. Now let's determine the value of p. Remember, we said earlier that in these kinds of parabola, the focus f is going to be 0p. Therefore, the value of p in here is going to be 2. Okay, it's this one. They are going to be the same. So with that said, we're going to use this same value of 2 and put it in here and simplify the equation. Okay, so let's do that one now. So this is going to be x squared is equal to 4. What's the value of my p? It's going to be 2. 2 and then times y. So further simplification will give me 8y. Okay, so this is now the equation of my parabola with this given focus and vertex. Okay, so let's analyze. The value of our p is actually equal to 2, which is actually greater than 0. So that means that the parabola is going to be concave up. It's going to be concave up. CCU, concave up, or it's going to be opening upward. It's going to open upward. Okay, that's the first understanding. Second, I already know my focus, and my focus is located at 0, 2. Also, my vertex V is 0, 0, which is actually they are given here. Yeah, they are given here. Now my directrix. My directrix is going to be located at, also what is the opposite of this? This is going to be y is equal to negative p. So if we're going to put in the value of our p in here, negative multiplied by the value of p is 2, therefore our directrix is going to be located at y equals negative 2. Now there is one thing that I would like to teach you in here. It's called the latus rectum. The latus rectum is going to determine how wide is going to be your parabola. So in order for you to understand this, the coordinates for your latus rectum is going to be plus minus 2 times the value of your p and then your p originally in here. So in this case, the value of your p in here is only 2. So let's put our coordinates for latus rectum. That's going to be plus minus 2 times our p in here is 2. So that's going to give you times 2 and then 2. Simplifying it further, this is going to give me plus or minus 4 and then 2. Okay, so I'm gonna show you why do we need this latus rectum when we're going to be graphing it. So this is one of the key one. We also need the directrix, we need the vertex, and of course we need the focus. It's very important. So now let's graph it. Okay, let's graph it. Let me just use this part. Okay, so I'm going to draw here. Remember, it's not going to be accurate, but at least you know what I'm trying to draw in here. So this is how we sketch the graph. Okay, this is your x and y. Okay, so my vertex is located at, this is our vertex, that's gonna be our 0, 0. And then the focus is located at 0, 2, and 0, 2 is here. F is 0, 2. So I'm going to point that. And then the latus rectum. So remember your latus rectum. The latus rectum is going to be plus minus 4, 2. So the latus rectum is going to be actually going through here. So let's count 4 units here. 1, 2, 3, and 4. And the other side is 1, 2, 3, and 4. This is going to be 4, and this is going to be negative 4. And then it's going to be on 2. Okay, this is going to be our 2, and this is going to be our 1. Okay, so I'm just going to connect them this way. Okay, so on this side, you have your negative 4, 2. And this is the coordinates for your latus rectum on the right side. So having said that right now, okay, then I'm going to just create my or draw my parabola, and that's gonna be finishing my task. So it's gonna be here. I'm gonna use another color. So here it's going to be doing this way, and it's going to be from here, the latus rectum is gonna be going this way. Okay, oops, it's okay. So our graph will be looking at this way. Now you are going to take note in here, because the latus rectum is going to actually tell you how wide is your parabola. Okay, so this is a little bit more of information that you're going to understand when you're going to be graphing your parabola in your practices. Okay, so we have done the first one with additional information. Now let's do number 2. They are actually identical. Find the equation of the parabola with a vertex 0, 0 and a focus of 0, 6. Having said that, our focus is 0, 6, then it means that our 0, 6 is somewhere in here. This is going to be 0, 6. So it means to say that our parabola will be opening up again. Okay? So let's see. Our equation is in the form again of x squared is equal to 4py. Okay? The value of p in here is going to be 6. This one, okay? So if you're going to be looking at this one, that's going to be your p. Okay, and also we're going to put that p in here. Okay, let's simplify it now. This is gonna give you x squared is equal to 4 times 6y. So it's gonna give you x squared is equal to 24y. So this is now going to be your equation. Okay, so we are actually given already the vertex, which is the very important one, our focus. Now we're going to find our directrix. The directrix is going to be also within the y-axis, therefore that's going to be y equals negative p. Okay, substituting the number of that, therefore our y is going to be on the negative 6. Hold on, there's something that I forgot to draw in our graph in here, and that is our directrix. Yeah, our directrix is located at negative 2. So here 1 and 2, this is going to be our directrix. Okay, which is y is equal to negative 2. Okay, going back to the second exercise. So now our directrix is located at y is equal to negative 6. Okay, the latus rectum, how wide is gonna be our graph? So that's going to give you plus minus 2 times p and then your p. Okay, so this is going to be plus minus 2 times 6. Our p is 6 only, then 6. So simplifying further, the coordinates of our latus rectum is going to be located at 12 and then 6. So this is going to be a little bit wide. Okay, so let's graph our parabola now. First, we're going to put our, or to mark our vertex at 0, 0. Okay, 0, 0. So we know that very well. Now this is our 0, 0. And then our focus is 0, 6. Okay, so let's count this one by 2. This is going to be 2, 4, and then 6. Okay, this is going to be 2, 4, 6, 8, 10, and 12. And as much as this is going to 2, 4, 6, 8, 10, and 12. This is going to be negative 12. And we have here 2, 4, 6. This is going to be negative 6. Okay, so why I'm labeling this? Because of my latus rectum, which is 12 plus minus 12, 6, and then also we're going to have our directrix at y equal to negative 6. So let's draw our let's plot our focus at 0, 6. Okay, remember 0, 6, 2, 4, 6. So this is gonna be our focus. That's gonna be our focus, f 0, 6. Here's gonna be our vertex. That's gonna be our vertex at 0, 0. And y is equal to negative 6. This line now is going to be our directrix d. Okay, which is having an equation y equals negative 6. Okay, our latus rectum is going to be 12 negative plus or minus 12, 6. So that's going to give you, first I'm going to do here 12, 6 here. And it's going to be negative 12, 6 here. So this is how wide my graph will be. So from here, I'm just going to do it this way. Okay, it's not accurate. Okay, but you can see what I'm trying to do here. Okay, so this is now how wide is our graph in here. So if you're going to take note once again that the latus rectum, okay, is going to tell you how wide will that be, okay, when it comes to the size of your graph. Okay, let's not forget to put that arrow in there. Okay, so this is now the graph of our parabola with the equation x squared is equal to 24y. Okay, let's try to find the equation of the parabola from the given graph in it. So we're going to be getting its vertex. Okay, the vertex of this is 0, 0. And the focus is F is going to be taken at 0, 2. Okay, so we are asked to actually get the equation of this. So with this given information, the graph is actually in the form of x squared is equal to 4py. Okay, so we're going to get our equation here now. X squared, here in this case, our p is equal to 2. Okay, remember that your p is at your focus. This 2 is the same as your p, and it's also the same on this. So we're just going to substitute these numbers on this. So it's going to be 4 times 2 times y. Therefore, x squared is equal to 8y. Okay, so this is the equation of this graph. Okay, number 4. Find the equation of the parabola shown. So let's look at the vertex. The vertex is still located at 0, 0, and the focus is located at 0, negative 3. So with this information, our graph is going to be on this format. X is equal to 4py. Now another reminder that remember that your p in here is going to be your focus in here. Okay, so the value of our p in here, your p in here is equals to negative 3. Now another thing that you have to take note is because the value of our p is negative, which is actually p is less than 0, that the graph is concave down. Okay, concave down, or it's gonna be opening down. Okay, let's find the equation of this graph. X squared is equal to 4 times negative 3y. Therefore, the equation is going to give you negative 12y. Okay, so here we're going to be finding the focus and the directrix of a parabola from its equation. Okay, so let's go for number 5 here. Find the focus and directrix of the parabola y is equal to negative x squared and sketch the graph. Okay, so in this case, I can say that this is going to, it should be in the form of x squared is equal to 4py. Yeah? So what I'm going to do here is I'm going to divide both of them by negative 1 and then negative 1. So this is going to actually give me x squared is equal to negative y. So in this case, we can see now that the value of our py here, the value of 4p here is equal to negative 1. So we're going to find p here. So 4p is equal to negative 1 divided by 4. Therefore, our p here is equal to negative 1 over 4. Okay. So what is this p all about? This is your focus. Since the vertex is located at 0, 0, and the focus then is also located at 0, negative 1/4. That is where the focus is. Now the directrix. The directrix is going to be located at the opposite side of this one. Okay, if you're going to be looking at your negative 1/4, your negative 1/4, because this is going to be opening down. Okay, because our p in here is less than 0, negative 1/4 is less than 0, so that's going to be opening down. So it means to say that our directrix is going to be the opposite of this focus. Okay, so that's going to be, our directrix is going to be located at y is equal to negative 1 over 4. Okay, oh sorry, it should be plus 1 over 4. Okay, so let's graph or sketch the graph now. That is one of the requirement in here. You have to sketch the graph. Okay, so since it is just a sketch, it's not going to be actually very, very accurate. So Let's see, I'm going to make this, let's say this is as big as this one. That's gonna be 1, and this is gonna be my 2. Okay, reason, because I have 1/4 in here, negative 1/4. Okay, so this is going to be 1/2, and this is going to be 1. Cut it again, that's going to be 1.5, and this is going to be 2. Okay, so our vertex is located at 0, 0. Okay, our focus is located at 0, 1, negative 1/4. Okay, it's really very low. Okay, I'm going to use a different color here, this one. It's gonna be the red one. So it's really very low. That's going to be your negative 1/4. Also, our directrix is going to be very, very small also. So I'm just going to use another color in here. Okay, so here, it's going to be equidistant with these two, so it's somewhere here. Okay, so if I'm going to draw my directrix, this is going to be my directrix, which is y is equal to 1/4. Now, our focus here is located at 0, negative 1/4. And our vertex is located at 0, 0. Now, the latus rectum. We need to know the latus rectum for us to be able to graph our parabola properly. So the latus rectum coordinates will be plus minus 2p and then the p. So in this case, the value of our p is negative 1/4. So that's gonna give you plus or minus 2 times negative 1/4 and then comma negative 1/4. Simplifying further, so this is going to give you, okay, I'm just going to cancel this one and this one. This is going to give you 1 and this is going to give you 2. So it's going to be located at plus or minus 1/2. Okay, 1/2 and then negative 1/4. So this is going to be our latus rectum coordinates. Okay, so let's do that. Plus and minus 1/2, which is really totally very small. So if I'm going to say this is going to be my 1, okay, here this is going to be my 1, then 1/2 is somewhere here, okay? So it's going to give me plus or minus 1/2 and 1/4, which is going to be passing through my focus, okay? So it's going to be this way, and that way, this way, and that way. So if I'm going to now create my graph, it's going to be going this way, this much only. Okay, so that's how we actually solve this problem in number 5. Okay, in number 6, the equation of parabola is x squared is equal to 8y. Find its focus and directrix and sketch its graph. Okay, so here it is already given that our vertex is located at 0, 0. Okay, now we're going to find our p. Here, this is in the form of x squared is equal to 4py. Now, this 8 is equivalent to that 4py, so let's equate that one. 4p is equal to 8, therefore, finding p now is going to be 8 divided by 4 is going to give you 2. So the value of our p is 2. That's gonna tell me that my focus now is going to be located at 0, 2. And my directrix now is going to be located at y is equal to negative 2. My latus rectum is going to be, the coordinates will be 2 times p and then p. Therefore, this is going to give me 2 plus minus 2 times 2 and then 2. Furthering, simplifying further, that's going to give me 4 and then 2. So this is the latus rectum. So let's sketch the graph now. Okay, it's just a sketch. It's not really very accurate, but at least we can see how it looks like. Okay, so my vertex is going to be at 0, 0. Next is going to be my focus, which is at 2. So this is going to be our F, 0, 2. Next is going to be our below here is going to be what you call your directrix, which is y is equal to negative 2. Now the coordinates of my latus rectum will be this one. Okay, so let's look at this one. These are coordinates plus 4. So let's put, say, 1, 2, 3, and 4. The other side is 1, 2, 3, and 4 also. Okay, and they're going to meet somewhere here because that is where the focus is. Okay, the focus is important, ladies and gentlemen. So I would like you to always remember that the focus is the main lesson or main part of our lesson in this video. Okay, so this is the graph of our parabola. Okay, horizontal parabolas with vertex at the origin. Okay, parabolas with horizontal axis, the graph of the equation is going to be y squared is equal to 4px. Now let's look at its properties. The vertex is still located at 0, 0, but this time the focus is going to be changing. It's going to be p0. It means that the focus is going to be lying on the x-axis, and the directrix is also on the x-axis, which is going to be the value of negative p, which is our negative focus. Okay, now the parabola is going to be opening right. Okay, if p is greater than 0, and it's going to be opening left if p is less than 0. So let's look at this one. If you're going to be looking at this one, the value of p in here is going to be 0. That's why it's going to be opening on the right side with your directrix on the negative side of it. Your vertex is at origin. And if your p is going to be less than 0, then it's going to be opening on the left side. Okay, this is still going to be your vertex at 0, 0, and your directrix right now is going to be on the positive side. Okay, so let's look at some parabola with a horizontal axis. Okay, a parabola has the equation 6x plus y squared is equal to 0. Requirement A, find the focus and directrix of the parabola and sketch its graph. Okay, the first thing we're going to do is to put the equation in its proper form. Okay, this should be on the form of y squared is equal to 4px. So we're going to transfer that into that. So that's going to give you y squared is now equal to negative 6x. Okay, let's find the p. Remember that this is going to be your 4px here is going to be this one. So let's equate it. Let's find p. So 4p is equal to negative 6. Dividing both sides with 4 by 4, p now is going to give you negative 6 over 4, or in its simplest form, that is going to give you negative 3 over 2. Since our p is equal to negative 3 over 2, and that's going to be less than 0, it means that our graph is going to be opening on the left side. Okay, so it will be looking this way, something like this. Okay, so having said that, okay, let's now get our important information. The vertex is at 0, 0. Now the focus F is going to be located at negative 3 over 2 and then 0. And of course our directrix is going to be on the x-axis. That's going to be x is equal to 3 over 2, the opposite of your directrix in here, this one. So if you notice that one, I'm still going to be just using the opposite of that, and that's going to be my directrix. Another thing that I would like to add in here is the coordinates of our latus rectum. Okay, the latus rectum is going to tell you how wide or how small is going to be your graph. That's going to be p, comma, plus minus 2 times the value of your p. In this case, the value of your p is negative 3 over 2. So the first coordinate is going to be negative 3 over 2 and then plus minus negative 3 over 2 times 2. Okay, canceling this 2 is going to give me only plus or minus 3. So the coordinates is going to be negative 3 over 2 and then plus or minus 3. Okay, that's it. So let's sketch the graph now. So what are the things that we're going to look at it? First is our vertex is at 0, 0. So the vertex is 0, 0. This is our 0, 0. The next one is our focus located at negative 3 halves 0. So negative 3 halves is going to be 1.5. Okay, so let me just put this one as interval 1 and then 2 and then 3. Okay, here is going to be 1. This should be negative. Okay, this is going to be 1, 2 and then 3. Here we're going to the highest part of our latus rectum is going to be 3. So we're going to do the same thing. 1, 2 and then 3. Here is going to give you negative 1, negative 2 and then negative 3. So our focus is negative 3, 0. Negative 3 halves is going to give you as 1.5. Okay, so that's gonna be here, negative 1.5. This is going to be our focus. That's going to be negative 3 over 2, 0. Okay, this is going to be our vertex at 0, 0. Now our directrix is going to be located here, this part. Okay, this is going to be your x is equal to 3 over 2. Now the latus rectum's coordinates is going to be negative 3 over 2 plus or minus 3. So it's gonna be somewhere here. Okay, let me just negative 3. Let me point out the 3 here. So it's going to be going through here, and the other side is going to be here. Okay, so if we're going to be putting our graph together, it's gonna be looking this way. Okay, this is how our graph will look like. It's gonna be opening left because the value of p is less than 0. Okay, so I hope you understand this one. These are called your horizontal parabolas, and they are very fun to really learn it. Okay, number 8. Okay, it's identical with the first one. A parabola has the equation y squared is equal to negative 24x. So this is already in its original form, which is going to be y squared is equal to 4px. Yeah, but that 4px value is going to be negative 24. So let's find p. Okay, let's find p. Let's equate it. 4p is equal to negative 24. Dividing both by 4, our p here now is going to give you negative 6. So our p is negative 6. So since our p is negative 6 and negative 6 is less than 0, it means to say that it's going to, our graph will be opening again on the, to the left side. Okay, left side. Let's continue now. Let's get the information that we needed for it to be graphed. First, we need our vertex at 0, 0. Second one is the focus is going to be negative 6, 0. Then we're going to get the directrix is going to be the opposite. X is equal to 6. Okay, and now the latus rectum's coordinates is going to be located at P and then plus minus 2 times P. So that's going to give you P is going to be negative 6 and then plus minus 2 times negative 6. Okay, simplifying further, this is going to give me negative 6 and then plus or minus 12. Okay, so let's graph the information that we have been taken earlier. So first, my vertex is at 0, 0. Okay, that's gonna be our vertex at 0, 0. Next is going to be our focus. The focus is negative 6, 0. 1, 2, 3, 4, 5, 6. This is going to be your 6 here. And then 1, 2, 3, 4, 5, 6. This is going to be your 6. 2, 4, 6, 8, 10, 12. Okay, this is by 12. 2, 4, 6, 8, 10, 12. Negative 12. Okay. Okay, so I'm going to create my directrix in here at x equals 6. Here x is equal to 6. My focus is located at negative 6, 0. This is going to be my focus here. My f is equal to negative 6, 0. Okay, and the latus rectum is going to be negative 6 and then plus or minus 12. So they're going to be meeting here and also in here. Okay, having all this information, I can now graph my parabola. So it's gonna be looking this way. Okay, it's not accurate, but we can use a graphing calculator to really make it more accurate. Okay, so this is now the graph of our parabola in here. This is the graph of y squared is equal to negative 24x. So now let's talk about the focal diameter of a parabola. Find the focus, directrix, and focal diameter of the parabola y is equal to 1/2 x squared and sketch the graph. So the first step we're going to be doing is to put the equation in the form x squared is equal to 4py. Okay, so let's write our equation in here. We have y is equal to 1/2 x squared. Okay, in order for me to put it in this format, then what I'm gonna do here is I'm going to multiply both by 2. Okay, so this is going to actually cancel this one, and on the other side you're going to have 2y is equal to x squared. Okay, so let's just fix this one. The final here now is going to be x squared is equal to 2y. So voila, we have that already. So from this equation, we're going to find p. Okay, here from this equation. Remember, your 4py here is going to be equivalent to 2. So if we're going to be equating that, 4p is equal to 2, then our p here now is going to be 2/4, or simply equal to 1/2. So having said that now, then our vertex is going to be at 0, 0. Then our focus is now going to be at 0, 1/2, and that's gonna give us the directrix. That's going to be y is equal to negative 1/2. So let's also find the coordinates for our latus rectum. The coordinates of your latus rectum is plus minus 2 times the value of your p and your value of p in here. Plus minus 2 times 1/2, and then your 1/2 here, sorry, 1/2. So we cancel that. The coordinates will be located at plus minus 1, and 1/2. So this is the coordinates of our latus rectum. Okay, so let's now sketch the graph. So this is going to be our graph. So I'll just make it a little bit big one in here because there's 1/2 in there. Okay, 1/2 is really very small. Okay, so here this is going to be our 1, and this is going to be our negative 1. So the graph is going to be at its vertex 0, 0, and this is going to be my directrix. It's located at negative 1/2. Y is equal to negative 1/2, and my focus here is located at here. The focus is located at 0 and then 1/2. Okay, my vertex is located at 0, 0. Now the coordinates of my lattice rectum will be this one, 1/1/2. So they're going to be passing through this one, okay, and then here. This is going to be -1 and +1. So if I am going to now graph my parabola, it's actually this much. Okay, this one, and from here it's going to be going this one. Okay, so these are your coordinates. Okay, this is your coordinates. On the left side you have your coordinates for -1 and then 1/2 of your lattice rectum, and on the right side you actually have your +1 and then 1/2 of your. Now let's talk about the focal diameter. Okay, the focal diameter simply tells you about this one. The diameter is going to be actually telling you the size from the focus to its point in the parabola. This is what you call your focal diameter. That's your focal diameter on the left side, and this is also your focal diameter on your right side. Now, for you to understand what a focal diameter is, this is going to be telling you how wide or how narrow is your graph. Okay, so the focal diameter is actually pertaining to the line segment that is starting from the focus going to the point in the parabola, one on the left side and also one on the right side. Okay, that is your focal diameter. Now the focal diameter is actually FD, we call it FD. Focal diameter is computed by multiplying 2 times the value of your P. So in this case, our P here is 1/2. So absolute value of 2 times 1/2 is just going to give you the absolute value of 1. Therefore, on the left side, I have 1 unit in here and also 1 unit in here. So that's going to be my focal diameter of 1 unit only. Okay, so I hope you understand what a focal diameter is all about. Okay, let's go for the next one. Number 10. Find the focus, directrix, and the focal diameter of the parabola y is equal to -1/8x square and sketch its graph. So first thing to do is to convert this one into this one. X squared is equal to 4py. Okay, so let's write our equation. Y is equal to -1/8 x squared. Multiply both by 8. Multiply both by 8. So this is going to be cancelled out. On this side is going to give me 8y is equal to -x squared. So to simplify further, that's going to give you now my x squared is equal to -8y. Okay, once again, the 4py here is going to be equals to 8. So let's equate that together and find p. Okay, find p here. Let's find the value of p. So that's going to be 4p is equal to -8, dividing both by 4. This is going to give me -2. So -8 divided by 4 is going to give you -2. So what does it tell me more? Because my p is -2 and -2 is actually less than 0, then that's going to be going, or open, my graph is going to be opening down. Okay, so let's get the important details that we needed to graph it. The vertex is located at 0, 0. Our focus is going to be located at 0, -2. And our directrix now is going to be located at y is equal to 2. Now, the latus rectum coordinates. That's gonna be on ±2p and then your value of p. Okay, so here that's going to be ±2 times -2 and then -2. So this will give you plus still 2, plus or minus 4 and then -2. So this is actually your coordinates for your latus rectum. Now the focal diameter is going to be the absolute value of 2 times p. So that's going to give you 2 times negative 2. Here is going to give you absolute value of negative 4. So that's going to give you 4 only. Okay, so let's graph our equation here, our parabola I mean. So here I'm just going to be doing this because it's going to be opening down. So it's going to open down. So what I needed is the focus is located at 0, negative 2. Okay, so here let's say this is going to be 1 and 2. This is going to be your negative 2 here, up there, 1 and 2. This is going to be your 2. And that 2 is actually your directrix. This is your directrix. And its equation is y is equal to 2. The vertex is going to be 0, 0. Okay, of course, our focus here is this one. It's going to give you 0, negative 2. Okay, here we're going to put our coordinates for your latus rectum. So 4 on the other side, 4 on the other side. So 1, 2, 3, and 4. 1, 2, 3, and 4. Not accurate, and they're going to be meeting within this. It's going to go through here. So this is their meeting point. Okay, on this part, this is going to be their meeting point. And now we can now graph it. Okay, so it goes this way. The other side, it's going to be going this way. Okay. So earlier, we said earlier, and we also see that the focal diameter here is only 4. So let's see if that is correct. So from this one to this one, you're going to have 4 on the other side. Okay, that's going to be actually 4. That is only 4 units. And on the other side is also 4 units, which confirms our calculation for the focal diameter. So the focal diameter is only 4. Okay, finding the focal point of a searchlight reflector. Okay, here's the situation in here. A searchlight has a parabolic reflector that forms a bowl which is 12 inches wide from rim to rim and 8 inches deep. If the filament of the light bulb is located at the focus, how far, this is the question in here, how far from the vertex of the reflector is? Okay, this is very nice. So let me redraw this one. So if I'm going to put it in the coordinate system, yeah, it's actually going to form a parabola. Okay, so this is going to be something like this. Okay, so let's say it's going to be something like this. Okay, so it says that this is going to be from rim to rim. That's going to give you 12. Okay, so one side is 6 and the other one is 6. So if I'm going to write that properly, so this is going to give you negative 6, and from here to this point, that's going to give you 6 also. So this point in here now is going to be given by, it says 8 inches deep, right? So from here to here, that's going to be, the distance of here is going to be 8. Okay, so that's 8. So this coordinate in here is going to give you 6, 8. Okay, and in the other side is going to be negative 6, 8. Okay, we only need this part for us to be able to find the focus. Okay, so this is going to be in the form of x squared is equal to 4py. Now what we have here is only the coordinates of x and y. So let's use this information to get this one. So here I'm going to put my 6 in here. So 6 squared is equal to 4p. I don't know my 4p yet, but I know my y. That's going to be 4py. So this is going to give me 36 is equal to 4 times 6 is going to be 32p. Okay, so if I'm going to be simplifying this one, divided by 32, then my p is equal to 9 over 8. Okay, 9 over 8. 9 over 8 is approximately 1.125. Okay, so we can actually estimate that. So to answer the question, how far from the vertex of the reflector is? So we have the P in here right now. It means to say that the focus is located at 0, 9 over 8. Okay? So what else? So the distance between the vertex and the focus is 9, 8. Okay. So that's going to give us its location already. Okay. So let's answer that one. So the filament is going to be located, this is going to be 9 over 8 inches from the vertex. Okay, of the reflector. Okay, so this is all about parabolas under conic sections. If you find this video helpful, share, like, and subscribe. Thank you very much.